Morning students, I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today we are going to begin an extreme important topic called basics supervised classification task. Before we even touch deep learning models, we must clearly understand how machine takes decision. So every day you take decisions like yes or no, true or false, select or reject. Similarly, machines also take decision, but they do it using data. This decision-making process is called classification. So by this end of the topic, you should be able to explain how a machine learns to classify data, what kind of data it needs, and how we measure whether the decision is correct or not. Can you give me one real life example where a discussion has one limited choice? Somebody? Okay, think about the topic. We're going to explain the next slides. So this slide shows how today's class is planned. First, we're going to recall what we already know as your brain is warmed up, and then we'll do a small thinking activity. After that, I will slowly explain the core concepts with the examples. Finally, we'll summarize and checking your understandings. And this method is important because machine learning is not about memorizing definitions. It is about understanding how systems behave. If at any point you feel confused, that is normal. We are learning something completely new. And in recap, it's a basic block diagram of a supervised learning workflow. And let us quickly revise what is machine learning. So machine learning means teaching a computer to learn from experience just like humans. In traditional programming, we write rules and computers follows them. In machine learning, we give data and computer finds the rules by itself. Now, data can be classified into two types, that is labeled one and the unlabeled data. Labeled data means we already know the correct answer. For example, an email already marked as a spam or a not spam. And supervised machine learning always uses unlabeled data. So classification is one of the most important supervised learning tasks. So classification and regression. So here, now let us clearly differentiate what is classification and regression. This confusion is very common for beginners. So in classification, output is a category. For example, yes or no, like true or false, or whether the patient has a disease or no disease based on the test results. So like the binary data are called classifications. In regression, the output is a number, that is a numerical data, the continuous numerical data such as marks, temperature, house price prediction based on the features like how many BHAs are there and in which plot about the location landmark likewise. So if you ask to predict whether a student will pass or fail, it is a classification. So if I ask you to predict the exact mark, it is regression. So now I think you clearly understand what is classification and what is regression, right? So understanding this difference is extremely important for exams and real world applications. So next, here what is supervised classification? So here, training data is the teacher of the machine. If the teacher is weak, the student will also be weak, right? So supervised classification models learn patterns only from the trained data, from the training data which we provided as an input. So, for example, if we train a disease detection model using only healthy patient data, it will fail completely. So, a supervised classification model learns pattern from the training data. So, if the data is incorrect, biased, or too small, the model will make wrong prediction. So, that is why data collection and data quality are critical steps in machine learning. So always remember the sentence, better data leads to give a better model. Tells about how reliable positive predictions are. So recall, let us how many actual positives we correctly identify. So in medical diagnosis, recall is very important because missing a disease is a danger. So these metrics helps us judge models are more intelligently. So the next one is ideate part. So there are many algorithms for classification and each works differently. Here logistic regression, see here logistic regression, it is simple and fast. It can use work in both classification and regression too. The name might be a regression, but it might be useful work on both the supervised learning task. And then was decision tree. Decision tree is easy to visualize and explain. And then random forest combines multiple trees to improve its accuracy. And SVM stands for support vector machine. It creates a boundary to separate classes. And KNN stands for K nearest neighbor algorithm, which makes decision based on nearby data points. And there is no single best algorithm. The choice depends on data sets, complexity, and problem type. And then accuracy versus interoperability, that is speed versus. These are the when selecting an algorithm, we must take a trade-off. Some models are highly accurate but difficult to understand. Others are easy to explain but less accurate. In real-world applications like banking or healthcare, interoperability is sometimes more important than accuracy. So algorithm selection in a design decision, not a random choice. And then experimenting like imagine applying different algorithms to the same data set, you will observe different accuracy and behaviors. So this activity teaches you the experimentation is essential in machine learning. You should never blindly trust one algorithm. Always compare and evaluate which algorithm is best suitable for your data set. And then applications like supervised classification is everywhere in email detection, face recognition, medical diagnosis, loan approval, and in recommendation systems. Once you understand classification, you will start seeing machine learning around you. Then summary of today's classes, we saw what is supervised classification. Predicts labels using past label data. It follows a structured process, understanding the problem, preparing the problem, choosing the algorithms, and evaluation. So this topic forms the base for all advanced deep learning classifiers. So this is the mind map of today's class, what we learned about supervised classification algorithms and its types of classification algorithms. So it revises it slowly, focusing on understanding concept rather than memorizing. In next class, we move towards what are the types of neural network and how it optimizing classifier using gradient descent. So thank you everyone. I catch you in another video. Bye.